Students, just reply. Am I audible? JNV Satara, JNV Osmanabad, Dahod, Ahmedabad. Everyone, please reply. Am I audible to you now? Kolhapur. Okay. JNV Ahmedabad is saying yes, sir. Okay. So now I'm assuming that I am audible to everyone. So now in the previous section, we have discussed, I hope you remember, everyone remembers, we discussed unit and dimension. Now we are going to study the second part of it. We have discussed few things there. So now let's start. Now the thing is conversion of units. What we have studied what are units, what are dimensions. Now in this particular case, we are going to study like how we can convert one unit into another unit, like from MKS system or from SI system to the CGS system. So one thing that everybody knows from the previous class, I hope everybody remembers, that we have learned that N1U1 is equals to N2U2, where N1 and N2 are the numbers and U1 and U2 are the units. So this is the basis on which we can convert units from one system to another. Like we can take an example and you should learn using that example because this is an important concept. So what is the example that I am going to take? For example, you have a force of 1 Newton. For example, you have a force of 1 Newton and you want to convert it in CGS. Convert it in CGS. Try to be responsive so that I can understand whether you are understanding things or not. So first thing that I will say, whenever you want to convert from one system to another, there might be different questions. Some question might ask you that in some random system, they will tell you in some random system, mass of unit of mass is something 4 kg. It's not 1 kg, it's 4 kg. So in that questions, you need to do the same thing that I am doing here. So these are very popular questions. So first thing, you should write the dimension. You should write the dimension of force. So the dimension of force is M L T minus 2. Clear? Very good. Now after writing the dimension, what you should do, apply this relation N1U1 is equals to N2U2. This is our SI system and this is I am writing for the CGS system. In SI system, what is the force? 1. Magnitude is 1. What is unit? You can either you should remember the unit. Everybody will say that unit of force is Newton. So I am not going to deal with that Newton thing. I am going to write the unit using this term, which is MLT minus 2. That means M is kg, L is length, that is meter, T minus 2, that means second square. This is the unit. Clear? In CGS system, let's it is N2 and U2 is the unit. Now mass is considered in gram, centimeter per second square. Now you can simplify the things. If you simplify this, second square and second square will be cancelled. So that will become kg. You can write in terms of gram, that is 10 to the power 3 gram. And this meter can be written as 10 to the power 2 centimeter is equals to N2 gram into centimeter. Now you can see that gram and gram can be cancelled, centimeter and centimeter can be cancelled, and N2 will become 10 raised to the power 5. So in CGS units, 1 Newton is equals to 10 raised to the power 5 CGS units, which is generally termed as dyne. In CGS unit of force is dyne. But you don't need to remember that thing. What is the result? You need to remember the steps. What we are doing, first of all, write the dimension, then N1, U1, N2, U2, convert it, put the values in the respective units and solve it. Things will be cancelled out. Clear, I think. So we will move further. Try to note down the things. Is there any doubt in this particular section? Clear? Okay, moving further. So there is a concept test. So it's your time to convert. I will give you one something minute to convert. So just try to be quick and solve this. Find 1 joule energy in CGS system. Can you do this? Say yes or no, first of all. If I name some particular Gandhinagar, Dahod, Ahmedabad, Bhavnagar, Osmanabad, Kolhapur, Rajkot, Satara. Yes, sir. You can do this. Very good. So JNV Ahmedabad is very confident, and everyone should be very much confident in this. I am giving you 1 minute. Try to solve it out. Okay, so I got some answers. I think 10 raised to the power 7, 10 to the power 7. I think that's clear. Everyone is saying. So I think there is no need to solve this particular question. I think this is clear to everyone. So I am writing here. If you whenever you see the notes, I am writing here everyone answered. Everyone answered. That means there is no need to solve this particular question. So I am moving further for the next question. Clear? Okay. So this is a question on your screen. That's the similar kind of question. What it says in a new system of units. They are saying not CGS, there is some certain new system. 4 kg is the unit of mass, 10 meter is the unit of length, and 5 second is the unit of time. Find value of 1 Newton force in the new system. So I am again giving you 1 minute to solve this question. Try to utilize the time, and I am waiting for your answers. Everyone be quick. If you solve this question, I will throw another question in front of you. Anyone got the answer? Okay. So I'm starting. In a new system, am I audible now? Am I completely audible? Okay. Very good, Gandhinagar. Okay, so now listen to me. First thing you should focus on is which unit you want to convert. So they are asking for 1 Newton. Newton is the force. So first of all, you should write the dimension of force. And what is the dimension of force? MLT minus 2. Everybody should remember these things. These are the basic dimensions. Now, after that, just apply N1 U1 is equals to N2 U2. Very good. Now they want us to convert 1 Newton. N1 is 1. U1 is, you can write it here, kg. M is for kg, L is for length, that is meter, divided by second square is equals to N2 times. Now, unit in this situation is not normal unit, it is 4 kg. In place of kg, you should write 4 kg because the question says unit of mass is 4 kg in a new system. And unit of length is 10 meter. So in place of meter, you should write 10 meter. Divided by unit of time is what? 5 seconds. That is 5 seconds, which is time square. Time square means 5 second square. Now you can cancel out the things if anything is there to be cancelled. So kg and kg, okay, 1.6. Kolhapur is saying, let's check it. Meter and meter. Second square will be cancelled with the second square. So here 1 will be remaining. And if you can see, this 5 will be squared. So that is 25 is equals to N2 into 10 into 4, 40. Very good. So you can cancel out the things 5, 8. So N2 is 5 by 8. Is it clear? N2 is what? 5 by 8. That means 1 Newton force in this particular system is 5 by 8. And we don't know the name of the unit. So I am not saying 5 by 8 units, I will say, because we don't know the name of the particular unit. So N2 is what? 5 by 8. You can simplify it again by in terms of decimals. You can write it whatever you want. But is this question clear to you? If it is clear, only then I will move for the next question. This question is important for both JEE and NEET. Please say yes or no. Be quick. Satara, Ahmedabad, Kolhapur. I think Kolhapur, your answer is wrong actually. I think you got something 8 by 5, I think, right now? So there might be a problem with the transfer of data, something like that. Otherwise, I think you got 8 by 5. Right. So I'm moving further. Ahmedabad is saying yes. Okay. So moving further for the next question. Now, again, the similar kind of question in a dash system. Now they have named the system as dash new system, something like dash system. Acceleration due to gravity is given as 5. And 15 meter per second speed is given as 10. Now what they are saying, that acceleration due to gravity, which is generally 10 meter per second square, is only 5 in that particular system. And 15 meter per second speed is given as 10. Find value of 1 meter dash in meter. Are you able to get the question? What question asked? First of all, your task should be that. Now, again, what is given? Acceleration due to gravity is given as 5. Now, what is acceleration due to gravity? We know that acceleration due to gravity is 10 meter per second square in our SI system. But in the dash system, it is given as 5. Dash system, that means in place of meter, you can use meter dash. In place of second, you can use second dash, which is squared. Is this first statement clear? The statement I have written, which is in the question. Now, in the second statement, they are saying what they are saying, and speed of 15 meter per second, that is 15 meter per second speed is equals to 10 meter dash upon second dash. Don't consider it as a power, it is dash. Okay. Let's suppose this is equation number one, this is equation number two. What we want to calculate? We want to calculate 1 meter dash in meter. Okay. So I think till now everything is clear. The two statements that were given. Now what I am doing, I am dividing these two equations. As soon as I divide these two equations, you can see that, just focus. This meter and this meter will be cancelled. This second will be cancelled with this second. Clear? Similarly, meter dash and meter dash will be cancelled. Second dash and power will be cancelled. Clear? So it will become 2 by 3 second is equals to 1 by 2 second dash. Okay. Someone might feel like what's happening here. So I'm just repeating the two statements I have mentioned in numerical terms. After that, I am dividing these two equations. So after division, what I got is on your screen. Now, can I get the relation of second dash and second? That means unit of time in new system to the original SI system. The relation is equals to 3 by 4 seconds. This is the relation between unit of time. Now, can you place these values in either of the two equations? You can place this value of second dash in either of the two equations. So I am putting it in equation 2 or from equation 2, whatever you want to say. I am putting this value. So equation 2, if I put, that is 15 meter per second is equals to 10 meter dash divided by second dash is what? 3 by 4 second. Now you can cancel out the things. Second and second will be cancelled. Clear? So it will become 15 meter is equals to this 4 will go in the numerator, that is 40 meter dash by 3. So meter dash will be how much? Can anyone solve it? 5 3s are 5 8s are, that is 9 by 8 meter. So what you got, that 1 meter dash is equals to 9 by 8 meters. Question is something different, but yeah, the basic idea is that you need to do what question mentions. You can't always go with the same pattern. Okay. So now tell me, is this particular question clear to you? After that, I will move further for the next question or next concept, I will say. If you want, I can repeat the same. Otherwise, I am moving further. Try to write down the questions. Clear? Moving further. Next is, what are the uses of dimension? The basic topic was that to establish relation among quantities. So we can use this method of dimensions to establish relation among quantities, but the condition is that the relation should be either of multiple or division type. Otherwise, we can't do the same. Statement is clear now. We can establish relation among quantities, but the condition is that the relation should be either of multiple type or division type. Otherwise, we can't do this. Okay. So before telling the conditions, I am just giving you an example that how we can proceed. For example, if I say like, if I say that kinetic energy, everybody knows that. I am saying the question says kinetic energy depends upon mass and velocity. The question is saying like that kinetic energy of a body depends upon its mass and its velocity and its speed. So can you establish a relation between for the kinetic energy? Can you establish a relation? So this is the statement. So for that statement, I will say, let's suppose kinetic energy is proportional to mass and velocity, but we don't know the powers, that how much power of velocity should be there, how much power of mass should be there. So I am assuming mass has a power A and velocity has a power B. Clear? This is the relation among the quantities. Okay, no problem. So you can write it as kinetic energy. You can remove the proportionality sign and you are putting some constant C, that is m raised to the power A and velocity raised to the power B. Now you can see that in this particular equation, from the principle of homogeneity, we know that dimension of each term must be same. That means dimension of kinetic energy must be same as the dimension of this whole whole RHS. So I am writing the dimension here. Dimension of energy is what? ml square t minus 2. This is the dimension of energy. C is a constant term, so you can't write the dimension for that. Mass has a dimension A and velocity, that is Lt minus 1, has a power B. Now, from the principle of homogeneity, dimensions of both terms should be same. If both terms dimension should be same, that means the dimension of mass here must be same as dimension of mass in this term. So you can compare the powers. After comparison, you can see that mass has a power A. So A in this term, mass has a power 1. So that means A is 1. Very good. Now again, L has a power B. That means B. In this whole term, L has a power B. Here L has a power 2. So that means B is equals to 2. So we have two unknowns A and B. If we have two unknowns A and B, we got two values of A and B. So I am putting this value. So what I got, kinetic energy is equals to C times m velocity square. This is the relation we get for the relation among the quantities for the kinetic energy. But this constant we cannot determine. This is the drawback. What is the drawback here of this particular application, that we cannot determine constants using this method, because constants have no dimension, so we have no particular way to identify the constants. I think this is the very fundamental question that I have given to you for an example. You can establish relation. I'm giving you for homework actually. What is your homework? That time period of a simple pendulum depends on length of the simple pendulum and acceleration due to gravity. Now you have to establish the relation. You have to establish the relation among these quantities. T is what? Time period of simple pendulum. L is the length of the simple pendulum. G is the acceleration due to gravity. You can establish the relation. And I think everybody knows the relation. So I'm not wasting a lot of time in that. Moving further so that you can solve some quality questions here. Limitations of dimensional analysis. I have told you the limitations already. So I'm not going there in deep detail. So now there is some questions for you. Let's do it. Okay. You have 1 minute to solve this particular question. Now, your participation is must in this particular question. if you can search, if you have some particular books of previous year questions, you will find that this is the most famous question of NEET and JEE exam. Most famous question of the this particular dimension chapter. In every test, like in your AIET, like in your chapter test, whatever test you are going to give, you will find this particular question in JEE Mains and NEET as well. Can anyone solve? Are you solving this question? Be responsive in the comment box. Anyone? Ahmedabad, Kolhapur, Satara, Dahod. Dahod, you are not responding in this particular class. Why? Rajkot. Am I audible? Am I audible? At least reply to that so that I I just can, what can I say? At least reply to that. Am I audible? Or I am just speaking to myself? Okay, so I'm going to solve this question right now. In a new system of units, force, momentum, and length are taken as fundamental quantities. Find dimension of energy in this new system. Okay, so they are asking the dimension of energy. So first of all, let's suppose energy is somewhat proportional to these three quantities like force, momentum, and length L. Clear? Now, if it is proportional to these quantities, then it must have some power. Let's suppose A, B, and C. These are the powers. Now, steps are very much clear. Write down the dimension of each term and compare the dimensions. These are the basic fundamental steps you should follow. So, if I start with writing the dimension of energy, that is ml square t minus 2. On this side, constant will have no power, no dimension, so I'm not writing it. Dimension of force is ml t minus 2 raised to the power a. Pressure is force upon area. Pressure is what? Force upon area. So you can write the dimension of pressure, that is mlt minus 2, that is force, divided by area, that is L square. So that will become m L minus 1 T minus 2 raised to the power B. And that is length. Length is again nothing but L raised to the power T. Now you want to compare, you need to compare all of these quantities and solve the equations so to get the values of A, B, and C. That is our final aim. So if I compare for mass M, M has a power A power B. So that means A plus B. In the overall term, mass has 1 power A from here, B from here. So they are multiplied. That is A plus B is equals to, if you compare it this side, that has power 1. So that is our equation number 1. If you compare for L, L has a power A. Okay. P is not pressure, P is momentum. Very good. Very good point highlighted by Gandhinagar boys. Very good, Gandhinagar. So we need to change the things here. What is the dimension of momentum? Momentum is mass into velocity. Mass has a dimension m, velocity has a dimension lt minus 1. Is it clear? And L is the length. Okay. Clear everything? So now you can write, actually it should be written in small p. Then that's my fault. Okay. Now compare the dimension of m. A plus B, A plus B is equals to 1. That is clear. Now for the L, if you say that is A plus B plus C. That means A plus B plus C is equals to 2. Comparing L. Now, if you can see these two equations, you can say A plus B is equals to 1, A plus B is 1, so C is also 1. So from this result, I can get C is equals to 1. Now, compare the dimension of T. If you compare for T, that means minus 2A minus B, only these two are there, is equals to minus 2. Clear? So minus minus can be cancelled out. 2A plus B is equals to 2 and A plus B is equals to 1. You can solve the equations minus 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 B and B. A is equals to 1. A is equals to 1. C is equals to 1. And you can see that if you put this A equals to 1 in this equation, you will get B is equals to 0. So now you got everything A, B, and C. Now put these values in the first equation, which is first equation in this equation, and you will get what is the dimension of E. You will get F and P raised to the power 0. That means there is no P. F raised to the power 1, momentum raised to the power 0, and length raised to the power 1. This is your answer. This is your final answer. So whenever they have given you some relation between quantities, like force, whatever it may be the relation, you need to follow the same process. A1, B0, C1. Very good, Kolhapur. Very good. That's good thing. I think question is clear to you. Everyone, moving further. Now you have some practice questions. Okay. This is the previous year question of 2019 mains exam. Tell me the answer. Now you have some 1 minute of time. Try to solve it out. I think this is a similar question. Okay. One thing that might confuse you, that you don't know, I am telling you, the quantity Young modulus. Listen to me. Don't worry, Young modulus. It is denoted by Y. I'm just telling you the formula. You should get the answer. Young modulus is nothing but stress over strain. Out of this relation, strain is dimensionless. The way I am telling you, in this way you can remember a lot of things. So strain is a dimensionless quantity. This is the ratio of change in length over original length. So try to figure out the things. And stress is what? Force per unit area. Stress is what? Force per unit area. So can you find the dimension of y? Can you find the dimension of y? First question is this. Y is what? Y is Young modulus is what? Stress over strain, out of which strain is dimensionless. So Young modulus will have a dimension of stress, and stress is what? Force per unit area. So first of all, tell me the dimension of Young modulus. After that, you can move further for the next part because it will be required in the question. Be quick. Be quick. We don't have a lot of time. Quick, quick, quick. Jaldi. Okay, someone has answered C. Okay, Gandhinagar, what is the dimension of Y? Force per unit, that is M L T minus 2 divided by area is what? L square. So that is M L minus 1 T minus 2. This is the dimension of Y. Now going to the question, what it says, if speed, acceleration, and force are considered as fundamental units, the dimension of Young modulus will be. So first of all, you will say dimension of Young modulus or Young modulus depends on these quantities, that is velocity raised to the power A, acceleration raised to the power B. Now tell me, whenever I am writing the units, tell me that A is the acceleration, because I will, whenever I see this capital A, it strikes to me or to everyone that it is going to be an area. So try to remember to avoid this mistake. And force raised to the power C. So I am writing the dimension of each part here. Whenever I write y, I have calculated the dimension of y, that is m l minus 1 t minus 2. Velocity is lt minus 1 raised to the power a. This is what? This is what? Not area. This is acceleration. Acceleration has a dimension lt minus 2 raised to the power b. Force has a dimension mlt minus 2 raised to the power c. Now, what I can observe here from you, that most of you don't know the basic dimensions. Basic dimensions means dimension of force, dimension of area, acceleration. So that might be a situation. Kolhapur is saying C option is correct. Okay. So a lot of options are coming as C. So let's solve it. After that, we will observe. So first of all, solve it for M. Check for M. M is not here, only here. So M has a power C, and in this case, M has a power 1. So we can say that C is equals to 1. C is equals to 1. How you can say option C is correct? In option C, you can clearly see that force has a power minus 2, but what we are getting C as a 1, that means force must have a power 1. So that means either option A should be correct or option D should be correct. Only these two options may be correct. Now solve for L. If I solve for L, L has a power A in this case, power B in this case, and power C in this case. That means A plus B plus C is equals to, what is the power of L here? Minus 1. So A plus B plus C is equals to minus 1, out of which C is 1. So A plus B is equals to minus 2. Let's suppose this is equation number 1. Okay, the code is saying option D. Okay, let's check. Either A or D will be true. That's final thing that we know that. Now compare for T. T has a power. Can you find the power? T has a power of minus A. In this case, T has a power of minus 2B. And in this case, T has a power minus 2C is equals to minus 2. Am I right? You can correct me if I am wrong. Minus A, minus 2B, minus 2C is equals to minus 2. So minus can be cancelled out from everywhere. So that will be A plus 2B. And C is what? 1. So that is 2 is equals to 2. 2 and 2 can be cancelled. So A plus 2B is equals to 0. And one equation, let it be equation number 2, and one equation is A plus B is equals to minus 2. You can solve it out. Option B. Okay. I think everyone is solving. So if you can solve it, minus minus plus, A and A can be cancelled. That is B is equals to 2. Now B is equals to 2. B is the power of acceleration, which is 2. You can place 2 here. You can place 1 here. Now, as long as I can see here, option D is going to be correct because we got two values. Now, if you can put the value of B anywhere, let's say in equation 2, I am putting the value of B. So A will be minus 4. So A will be minus 4. So V raised to the power minus 4, A square and F. So which is our option number D? This is correct. The Hood. Very good. D is correct. Now, Kolhapur, did you find what is your mistake in this particular question? Can you identify by looking at your solution? Just tell me, is this question doable? This is not the older question. This is new question 2019. Do you have an idea what kind of question they are asking in the exam? This is the simplest form of question. Be attentive, be focused, and you can solve the question paper. Answer is D. Very good. Another question. This is also from 2019. They are saying the density of a material in SI unit is 128 kg per meter cube in certain units in which the unit of length is 25 centimeter and the unit of mass is 50 gram. The numerical value of density. Can you see which formula you are going to use? What pattern you should follow in this question? Just after reading the question, first thing that should come in your mind that this is the question of the concept N1 U1 equals to N2 U2. How you can get this in your mind? But this is the gut feeling after reading the question. What is the feeling? That there is a certain value 128 kg per meter square and they are asking the numerical value in some different unit, in some different system. So can you solve it in 1 minute? N1 U1 N2 U2. Be quick. And I am expecting some answer from you. Kolhapur, this time don't make a mistake. Don't make silly mistakes because throughout the session you are making silly mistakes. Gandhinagar is saying option A. Very good. I think this answer is correct. Maybe incorrect because I don't know. It needs to be solved, but it might be 16. It might be 40. I don't remember the answer. Anyone else? Whatever, but Gandhinagar boys, you are very quick to respond and I really like it. So first thing you should follow is they are asking the density N1 U1 is equals to N2 U2. That's what we need to follow. You need to apply. N1 is what? 128. Unit of SI system is kg per meter cube. That's simple. Now, N2 we need to calculate. U2 is what? They are saying in certain units, unit of length is 25 centimeter, unit of mass is 50 gram. So in case of mass, you should place 50 gram. Are you getting my point? Because question says that unit of mass is 50 gram and unit of length is 25 centimeter. That is 25 centimeter, but it is cubed. So you need to cube it. Clear? Now you can simplify things by changing the values. So that is 128 is here. Kg you can convert it into gram. That is 10 to the power 3 gram. Everybody knows. You can convert meter into centimeter. that is 10 to the power 2 centimeter, but it is cubed. So 10 to the power 6 centimeter cube is equals to N2 into 50 gram divided by 25 into 25 into 25 cubed centimeter cube. Now you can simplify again. I can cancel out centimeter cube with centimeter cube, gram with gram. Now, this is the thing that I shouldn't do actually. I shouldn't do. So that is, can you see that 128 divided by 1000, it will become 10 to the power 3. This 50 will come downside, that is 50. And these 325s will go 25, 25, 25. This is what N2 is. Okay, 25 into 2. 25 into 40. Okay. Okay. Now you can again simplify. 4 tens are 4 threes are 4 twos are. Check me whether I am doing anything wrong or whatever. 2, 16, 5, 2, 5, 5. So N2 is equals to 2 8 that is 40. So don't look at that 40. Very good. So we are getting 40 answer. So N2 is what? 40. Are you getting? This is 2019 question. How easy is the question? Only simple calculation and you will get the answer. Now on this note, I am giving you another question. This is again 2019 mains. Now someone might feel like, sir, how many questions were asked from this chapter in the 2019? Students, there are lot of shifts in the exam. Like day 1, day 2, every day there is an exam. So different papers have different set of questions. So don't consider that all these 3 questions are from one paper. They are from same year, but from different question papers. Now this is interesting question. This is not which we studied today. Actually, this is from the previous class. The concept from the previous class. The question says the force of interaction between two atoms is given by something. Just focus on the formula. Alpha, beta, exponential, whatever. X is distance. K is Boltzmann constant. T is temperature. Now T is temperature. Alpha and beta are constant. The dimension of beta they are asking. Now, first of all, in the previous class, I have given you a table to remember. How many of you remember that I have given you a table? I'm not asking the table you have remembered. I am asking you that how many of you remembered that I have given you a table of dimensions, famous dimensions. And in that particular table, Boltzmann constant was there. And that table I have prepared based on my experience that these are some basic dimensions. If I can show you that table, if I can show you that table from the previous class, that table I was saying. Do you remember this table? During the last class, I have given you this table to remember. In this, you can see there is Boltzmann constant. There is Planck constant. You need to, what is the dimension of Planck constant? Boltzmann constant. Just look at here. ML square T minus 2 theta minus 1. You can find it here. Okay, Gandhinagar is saying option C. Very good, Gandhinagar. Let's check it. Very good, Gandhinagar. So let's go to the question. Where were we? Okay, I think this is the question. Okay. So try to solve it out. First of all, what it says, force is equals to alpha into beta into exponential raised to the power minus x square by alpha k and t. T is not time, T is temperature here. Now, in this equation, you need to find the dimension of beta. First thing that you should remember, you can recall it, that this whole term is dimensionless. I have told you in the previous session. And this term is also dimensionless. Individually, I'm saying that power is dimensionless and the whole exponential part is dimensionless. That means if you want to calculate the dimension of beta, or you can say from the principle of homogeneity, dimension of force must be same as the dimension of alpha and beta, because the remaining part is dimensionless. Everyone should listen. So to find the dimension of beta, you must know the dimension of alpha. For alpha, I will look at this part. So again, I am saying in this region that this whole term is dimensionless. That means x square negative has no impact. That means x square by alpha k is dimensionless. That means you can write 1. Option A is correct. The whole is saying. Okay, so there are 2 options we are getting. Now for alpha, you can say I'm writing the dimension of every part except alpha. So alpha I am taking here is equals to, I'm writing the dimension of x is the what? Distance. Distance means L square. Very good. Dimension of Boltzmann constant is ml square t minus 2 theta minus 1. This is the dimension of Boltzmann constant. Into T is what? Temperature. Temperature means theta. This is the dimension of alpha. So this theta and theta can be cancelled. L square and L square can be cancelled. So m minus 1 T square is the dimension of alpha. This is the dimension of alpha. Now put this value of alpha in equation like this. Force has a dimension mlt minus 2 divided by alpha has a dimension m minus 1 t square. This is the dimension of beta. So what you can see here, it will become m square L t minus 4. This is the dimension of beta. M square L t minus 4. Which option is correct out of the 4? Someone is answering. That is option C, JNV Bhavnagar. Very good. This is option number C. Are you getting? So you have committed few mistakes here. Everyone has committed. The Horde is saying A. Bhavnagar is A. Gandhinagar is A. Everyone was saying A. Okay. Okay. So now tell me. We can commit mistakes. No problem with that. But the thing is, after committing mistakes, can you identify your problems? Can you identify your mistakes? If you can, then you are going to be a successful person. If you can't identify your mistake or you overlook your mistakes, then it's going to be difficult for you. Are you getting my point? So I am not giving you some motivational words. I am just telling you, you need to figure out what's happening, why you are committing mistakes. One thing that I can consider here, I am not giving you proper time to solve the questions. You might be in a hurry, you are making mistakes. So I'm not sure about that, but there are other questions for you to try. But because of the foundation of time, I am ending the session here. I hope you enjoyed it. Tell me what you think, what you learned. If you can learn something from these classes, just tell me that we are learning something. Otherwise what? We need to take the classes. Okay. On this note, I'm ending the session. Anyways, you all were active in the class. So thanks for that. Bye, everyone.